Okay, so now we're going to talk about engineering functions. This is where your book is starting to piss me off. But your book has now started calling these things engineering requirements. So I'm going to switch the way I talk about these and start talking about them as engineering requirements. But keep that in mind. They're basically the same thing. I've been talking about the same thing this whole time. So, what's the task here? Well, the task is to take our needs, right? The needs that we spent so long figuring out and crafting carefully, and we're going to translate them into the language of engineering. Language of engineering. What's the language of engineering? Well, numbers, right? This is why engineering sucks and is awesome. We're good with numbers. And by numbers, another way to think about it is stuff we can measure, right? Stuff we can measure. So like pounds of unicorns, that's not a good engineering requirement. Cool. So this will include all the stuff from our needs that we figured out. It'll include stuff from benchmarking, right? We talked about how benchmarking can help us figure out some of our engineering requirements. Yeah, and that's basically it. The only way to really learn this stuff is to just start doing it and figuring out what are good engineering functions and what are not. Let's do some examples real quick though. Let's do the example of child safety seat, right? Oops, there's no E at the end. Let's cross that out. So with a child safety seat, right? We've talked about a lot of the needs of this. Let's talk about some engineering requirements. Well, one is going to be related to the crash. Related to the crash, the ability to survive a crash, right? So how do we talk about that? Do we talk about the force that this thing needs to withstand? No, right? It's not force, but acceleration, which I don't know why we call it G-force. That's kind of weird, but it's acceleration, right? If we have a 50-pound child in this car seat, in the exact same crash, that it's going to experience much more force than a 25-pound child, right? Much more force. So exactly twice, right? This is equal to m times, not m times g, but mass times acceleration, right? Awesome. So now the crash G-force, right? We need the chair to survive a certain acceleration, right? And we also need the child to survive a certain acceleration. Those might be two separate things, right? A crash that a child can survive might irreparably damage your chair and you need to get a new one. That's fine. Kid's alive. We're all happy. Awesome. What's another one? Well, two might be we have certain requirements on the weight of a seat, right? What's the weight of a seat? It's acceptable so that a person can get it in. 90% of our, or 95% of our customer base can get it in and out of a car. Let's talk about comfort. How would you translate comfort into an engineering requirement? This is difficult, right? Well, you could do you could put a bunch of babies into car seats and talk about the average time to tantrum, right? More comfortable a seat is, presumably, the longer it'll take a child to be angry. You could talk about the maximum pressure on a child of a given weight, right? Say 30 pounds. So make sure there aren't any pressure points so the child is comfortable, or what the weight is evenly distributed. There are also a couple more important things, like what about safety? What if you get into a car crash, right? You're going to care an awful amount about the average time to remove baby. Interestingly, well, actually I didn't read the primary source on this, but I've heard that in most of the world, 5-point harnesses are illegal for car seats because it takes longer to remove the baby. So if you're in a car crash and the car's on fire, it takes longer to remove a child. But we have 5-point harnesses to prevent the child from wiggling out of the car seat. So it's kind of interesting. So that's the safety one. 6, we care about the parents' quality of life, right? They want fast average time to I'm going to say install, but whatever, install baby. Clearly I do not have a child. So for each of these things, right, we can give units on what we're measuring. What are the units on acceleration? Because that's what we're measuring. The maximum acceleration is, well, that's meters per second squared, right? And we want these higher or lower. Well, we want them higher, right? So for every one of our engineering requirements, we ought to be able to say, what are the units on it? And then which direction do we want? Weight. Weight we're going to measure in, well, we're going to use SI units. Weights are in newtons, right? And we want that lower. Average time to tantrum, that's going to be measured in seconds. And we want that to be higher. Max pressure on child, that's going to be in pascals, or if we're breaking it down, newtons per meter squared. And we want the max pressure on the child to be low. Right? We want that weight evenly distributed. Average time to remove baby, that's going to be measured in seconds. We want the average time to be low. We don't want to take forever to remove your child. And the average time to install baby, we want that to be low, right? Good. So you're gonna do this. You're gonna create a whole set of engineering functions. And the important thing to remember is I have an arrow here from need to engineering function, but it's not a 1-to-1 relationship between needs and engineering requirements. Okay, it's not a 1-to-1 relationship. So a given need, one need you might have one engineering requirement, another need might spawn 3 or 4, right? There might be some needs that you just can't measure, so you don't put them in your engineering requirements. Okay. So they don't directly result in an engineering requirement, but there's not a 1-to-1 relationship. So you should actually in the end have more than needs. That's clear, right? What do we deal with in engineering requirements? All right, so we're going to take these engineering requirements after you develop these, right? And we're going to use something called quality function deployment to weight them, to give them an order, see what's more important, what's less important. That's next lecture, though.